Hi students, welcome to Honors Algebra 2. This is Mrs. Brunk. And today we are going to be taking a look back at the two ways to represent a quadratic function, the standard form and the vertex form. And we're going to take a look at what are the benefits of one versus the other, and then we're going to look at how we could take a quadratic function that's in one form and convert it to the other. So this sheet right here is just a little summary of the different methods we've looked at. And then just a reminder about the thing called the parent function. Let's start with that. So a parent function for a quadratic looks like this. F of x equals x squared. So that's called a parabola. And that parabola creates a U-shaped curve, which again is called a parabola. A U-shaped curve called the parabola. And the axis of symmetry is a vertical line that divides the parabola into two equal parts. And we saw that it's like the symmetry line, right? And the turning point of the graph is called the vertex. So on the parent function, that vertex is at 0, 0. The graph is positioned right at the origin, right? And then as we move to the right, let's say right 1 unit, if we squared 1, we'd get 1. And if we substituted in 2, if we squared 2, we'd get 4. And so we end up with a side of the graph that looks like this, okay? So one side of the parabola, and on the other side we have the reflection images of those points, because if we substitute -1 in and square it, we get +1. If we substitute -2 in and square it, we get +4. And so we see these points repeating on the other side of the y-axis. So that's our parent function. Now, whatever we do to x squared, if we add things to it, we multiply it by things, maybe we add a term that just has an x in it, all those things are going to change the position of the parabola and also change its shape in, like, not completely change its shape, but instead of making it be a parabola that looks like this, it might be a skinnier parabola, it might be a wider parabola, it might be a parabola that's facing downward, okay? And so we looked at two different forms. First was standard form, and that was f of x equals ax squared plus bx plus c. And technically this parent function is in standard form. It's just that the b is 0 and so is the c 0. It's like the a is 1, the b is 0, and the c is 0, so it turns out to simplify to just x squared. Now, its axis of symmetry is, in general, found by using the formula x is equal to the opposite of b over 2a. And then if we want to plug that back in, we can find the rest of the vertex. So here's an example. The axis of symmetry would be, and there in the x coordinate of the vertex, would be the opposite of -4, which is +4, over 2 times the a, which is 1. So that's 4 divided by 2, which is 2. So here at 2 on this graph, we have a vertical line that is the mirror for this graph, right? And if we wanted to, sorry about that. And if we wanted to, I was zoomed in really close there, I didn't see I was cutting that off. To make a table of values, we could start with 2 in the middle, and then we could plug in things below it like 1 and 0, and above it like 3 and 4, and we'd get those coordinates. So if we substitute in 2 to get the rest of the vertex, that would be 2 squared minus 4 times 2 plus 1, which is 4 minus 8, that's -4 plus 1 is -3. So this graph has its vertex, which in this case is its minimum point, right here at, it's hard to see where that axis is, but I think the axis is supposed to be right here. And I could just go ahead and substitute these other x values in, or I could identify things like, hey, the y-intercept. The y-intercept must be 1, so the point 0, 1 is on this graph, which would be right here. And then I could simply reflect that over and get its image, which is over here. And then with 3 good points, as long as the middle point is the vertex, is a pretty good amount of points to graph a quadratic. I mean, one more would be the ticket. So if we wanted to find one more, like say when x was -1 or y was like 5, something like that, then we could get a little better idea. But this is still a pretty good sketch of the graph. So what we learned about them in this form is we can see the y-intercept. We can use a little formula to calculate the x of symmetry and the vertex, and we can use the concept of symmetry to graph these things. Now, a vertex form looked like this. F of x is equal to a times x minus h squared plus k. And we knew that each of these things, a, h, and k, represented some change that you would make to the graph, whether it be its position, sliding it left or right, which is what the h does, sliding it up or down, which is what the k does, and then maybe making it skinnier or wider. If the A was greater than 1, it's going to stretch it, make it skinnier. If it was between 0 and 1, it would flatten it out and make it just wider, like flatter. Vertical compression. If there was a negative out in front, of course, it would reflect it down. Much like what would happen when it was in standard form if the A was negative. So it's the same situation, same A there. And the x of symmetry could just be found by looking at the h and the k. So looking at, the slide left or right, the slide up or down, because we assume it's starting at that origin 0, 0. So the x of symmetry would be would be x equals h, and then the vertex would be h comma k. Okay. So with something like this one, we can see that this graph is a reflection over the x-axis. It's got a 2 that's multiplying by, so that's a vertical vertical stretch. It is a slide 1 left, because if it was written as x minus h, it would be x minus -1, which makes it plus. And then finally, a slide 6 units up. So graphing something like this, what we might choose to do is imagine that we're starting at the origin and that we have the point 0, 0, and we just move it 1 unit to the left and 6 units up, 1, 2, 3, 4, 5, 6. And we know that the line of symmetry would be right here. Oops, let's see if I can write that in a different color. Here's the line of symmetry. We know this graph's going to face down. We could put that point at 1, 6, and then maybe we could pick a point or 2 on either side. Say we could plug in, that's supposed to be -1 and 6, so I could plug in -2, -3. I could plug in 0 and 1 on the other side, and I could come up with the other coordinates. Now, another idea about graphing is you could think about it as that 2 is stretching it vertically. So normally from the vertex on the parent graph, you would go, if you went to the right one, you would go up 1. But now instead, if I went to the right one, I'd go down 2, and then left 1 and down 2. Normally, if I went 2 to the right, I would have to go up 4 units, because when you square 2, you get 4. But now I know I'm going to have to go twice that. So if I went 2 to the right, I'd have to go down 8 instead. So that would be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. And then its image on the other side would be right here. Okay, or you could just simply plug those coordinates in to the function, and there's our graph. So we see that each of the different forms of a quadratic function have their benefits. They're things that lend themselves to make graphing easier. Like, for instance, with vertex form, you can easily see the vertex. But with standard form, you can calculate the vertex fairly easily, and then you can see the y-intercept right in the equation. So neither one is, perfect on its own. They both have their benefits. Now, if I wanted to, say, put this one right here, the vertex form, and put it in standard form, I know that that would involve me having to take x plus 1 and squaring it using FOIL. Then I'd have to distribute -2 through to each one of those terms, and then I'd have to, at the end, add the 6 in to combine with like terms. And I'd be able to put it in standard form. I'd get to expand it out. So standard form is like expanded form. But what about if I wanted to go the opposite direction? So let's say I wanted to take this one and I needed it to make it look like this. That looks much more complicated. And that process is actually called completing the square. And we'll talk about why that is here in a minute. Maybe you kind of have an idea. It's because see how there's a perfect square right in there, like a square binomial. And so what we're going to have to try to do to go from standard form to vertex form, we can't just expand out using like what we know about FOIL and adding like terms. We have to learn a new process, and that's what this lesson's all about. So in order to learn how to use this completing the square method to convert quadratics from standard form to vertex form, first thing we need to do is review what a perfect square trinomial. So a perfect square trinomial, remember, is one of those trinomials that starts with a perfect square. So we know that there's not really room on that line to fill this in, but there's A and C are perfect squares. And the other thing is that the B is equal to 2 times the product of the square root of A times the square root of C. So that was kind of our way of checking to see if we had a perfect square trinomial when we were factoring. Like we would say, okay, well, does our term start with a perfect square? Does it end with 1? And then if so, we take the square roots of them, we multiply them and double them and see if we get the middle term. Now, we didn't always have to worry about that when we were factoring because we could have just used guess and check or AC method to factor those. But we still did introduce what a perfect square trinomial was, and it's important here because in this lesson we're going to create perfect squares. Like I could look at x squared plus 8x plus 16, and I could factor it just by doing, just guess and check. Oh, 2 factors of 16 that add to 8, that'd be 4 and 4, so it turns out to be x plus 4 times x plus 4, which is x plus 4 squared. Okay, but I really want to emphasize this idea of checking to see if it is a perfect square because it's going to be important as we do this lesson. So instead I think about, okay, what is the number, and I don't like necessarily that they used a here instead of x's, but whatever. But if that starts with a 1 and ends with a 1, they're both perfect squares. And if I took the square root of the 1 and the square root of the 1 at the end, the square root of 1 is 1, the square root of 1 is 1, and if I take 1 times 1 and then multiply by 2, I get the middle term. So this is a perfect square trinomial. And how I can tell when I go to factor it, I know there's going to be 2 of the identical factors. They both have a and 1 in them. And how I know what sign is between them is the sign of the middle term, okay? So what about this next one? Again, this one starts with a perfect square. It's just 1m squared. So the square root of that is 1, right? And then the square root of the last term, which was 81, is 9. And 1 times 9 times 2 is 18. And that matches the middle term, but the middle term is negative. And all that tells me then that my factors will be m and 9, but now this time the sign will be minus. Okay, and there's 2 of them. So take a second and test to see if that next one is a perfect square trinomial and then factor it. Okay, hopefully quick check shows you that yes it is because the square root of 1 is 1. The square root of 25 is 5. So this is actually the square root of 1p squared, which would be 1p, right? And then the sign is minus. If I multiply those and double it, I get 10. So the sign is a minus. So that means it's 1p minus 5 or p minus 5 squared for my factors. 2 of them, so it's p minus 5 squared. Now sometimes the perfect square trinomials are a little more complicated. They might look like this, say like 4x squared, and then let's say this is 30, maybe like, let's go with like 81 at the end. And then, let's see, this would be 36 in the middle x. So this is a perfect square trinomial because I'm starting with a perfect square. So I've got that square root of 4x squared is 2x. The square root of 81 is 9. If I multiply those and double it, so 2x times 9 is 18x. Double that, that makes 36x. So that would be the factored form. I'd have two factors of 2x minus 9, which would be 2x minus 9 squared. So that's really important background to help us as we do this completing the square process. So what we're going to do is take from standard form and we're going to move to vertex form using these steps. If the standard form equation is a perfect square, like example 1 down here, now this one's a perfect square, I already know that, simply factor to convert to vertex form. If not, you can use a process called completing the square to write the equation in vertex form. So we're going to go ahead and do example 1 first, and then we'll go back and look at these steps. So we know that the square root of the first term is x. The square root of the last term is 2. If I multiply x and 2 and double it, I get 4x. So that means this is a perfect square trinomial. And so now I've written it as a square binomial, and now I just switched that from standard form, right? This was standard form, and now I've moved it down into vertex form, okay? It just happens to be a slide 2 to the left. And if you graphed the standard form version of that, you'd see that's the exact same one. You could graph x squared plus 4x plus 4 in your graphing calculator, and at the same time graph x plus 2 quantity squared, and they would be the exact same graph. They're just written in different forms, much like maybe back in Algebra 1 you looked at lines in slope-intercept form, y equals mx plus b, and then also you might see them written in standard form, and they could be the exact same line, but they look completely different because they're just set up in different forms. So you just don't know it until you get them in that form. Now, let's see if the next one is a perfect square trinomial. So if I take the square root of the first term, that would be an x, right? And then the square root of the last term, 18 is not a perfect square, right? So right away you think, I don't have a perfect square trinomial, what do I do? So now we're going to follow the steps. So step 1 says to group ax squared plus bx together. So in other words, they want us to just kind of take that constant term and sort of ignore it, okay? And actually what we can do is we can move it to the other side, okay? So that it's over here with f of x. And so when we, I'm going to rewrite that for a second. Because I know that 18 is not a perfect square, so I just want to get it out of the way so that I can focus on making a perfect square. So I'm going to create a perfect square out of the x squared minus 8x part, okay? And so to do that, what I have to think about is what do I have to add to this to make it a perfect square? And how I'll be able to tell, the easy way, because this is a pretty simple perfect square trinomial, as I work backwards, I just think what is the middle term, right? Since this starts off with 1, I think what is the middle term if I just cut it in half and square it? So I'm going to use this little formula, and this works again for any of these that start off already with a 1, x squared. So it's going to be the b divided by 2 squared, okay? So half of negative 8 is negative 4. If I square negative 4, I get 16. So I just added 16, but I also have to add 16 to the other side. I'm sorry, I'm going to rewrite that because I usually leave myself a little bit more space than that so I can add this on. So remember I took half of the b and I squared it, and I got 16, so I'm going to add 16 here. But then you know how that works with the addition property of equality. If you add something to one side, you have to add it to the other. So I have to add it on this other side. So now I've created this perfect square trinomial. So I'm going to go ahead and factor it now. Okay. So when I factor it, I'm going to get x and then a 4, and the sign will come from the middle term, so it'll be minus, and then squared. But then over here I have f of x minus 2, because I took the negative 18 and added 16 to make negative 2. And then the last step is, okay, now I got to get f of x by itself again to get in that function form, so I'm going to add 2 to both sides, right? And there's my equation in standard form, okay? F of x is equal to x minus 4 squared plus 2. So those two graphs, or two functions, this one right here and then the vertex form, those are the exact same set of points, the exact same graph. It's just that now I've switched it over into vertex form. So again, the steps were to sort of keep the x squared and the x together, okay, and move any constant term to the other side. So I did that. And then I figured out whatever I had to do to add to complete the square. Whatever I added to the one side, I added to the other. I then went ahead and factored the perfect square trinomial and brought the rest of whatever's left of the constant term back over to be on the right-hand side with my perfect square. And now I can look at this and right away I can just tell, hey, my vertex is at 4, 2. And just like this one was at negative 2, 0. Okay. So let's try another one. Okay, so I'm actually gonna, let's see, be looking at one that starts off with a negative x squared. So this time, like a negative leading term there on the x squared means, well, this can't be a perfect square. So I know right away this is not a perfect square trinomial. So I'm gonna have to, you know, try to go through this process again. So the first thing I could do is I could move that 5 to the other side. So I'm going to do that. So when I do that, I end up with f of x plus 5. So essentially I'm just going to move that 5 over, get it out of the way on the other side. Okay, so I just move that over, right? So then what I want to do is I want to get rid of that negative in front of the x squared. And so how do I do that? Well, I could just factor out a negative 1. And what that leaves is x squared minus 6x, right? So I had already moved the 5, right? So the 5 was over on the other side. The negative 5, I moved it over and became positive 5. Now I factored out the negative 1, leaving me with x squared minus 6x. And now I'm just going to focus on the x squared minus 6x and figure out what would I have to add to make this a perfect square. And whatever I add here, right, I'm going to add the exact same thing on the other side. So let's think about, we're going to take half of, so we take negative 6, we divide it by 2, and then we square it. So half of negative 6 is negative 3, and if we square negative 3, we get positive 9. So I'm going to add 9 here. But in reality, I didn't actually add 9 to this right-hand side. I added negative 9. Because if I were to go now and distribute that negative 1 back through, that's technically a negative 9. So here on this other side, I'm going to add negative 9 to the left-hand side. So we're adding negative 9 really on both sides. Okay. So now let's clean up this right-hand side. That would be f of x minus 4. Okay, I'm going to put the negative 9 and the positive 5 together. Okay, I'm going to factor this down to a square binomial. So remember, we take the square root of the first, which would be x, the square root of the last, which is 3, and then we get the sign from the middle term, which is minus. Okay, one last step. So we're almost there. We're almost in vertex form. And the last thing we have to do is simply add this 4 to both sides. Right? We're going to add the 4 here, add the 4 here, and that leaves us with negative 1 times x minus 3 squared plus 4. And that's our function. Now, you don't have to have the 1 there. You could take the 1 off and just leave it as negative. And then when we look at that, we can see, oh, that's a reflection over the x-axis. That's what the negative does. The x minus 3, that part's moving it 3 units to the right and then 4 units up. And if you type that in your graphing calculator, you can see that, in fact, that is what it does to it. And it also is the exact same as this original function here, negative x squared plus 6x minus 5. And just in case you are wondering what all this racket is in the background, this is the current situation for my dog Harlow. She really lives a very rough life. She's laying on the back of the couch, snoring up a storm. So pardon all the ruckus in the background. Okay, and I forgot to actually list the vertex. So the vertex would be 3, 4, because this is moved 3 units to the right and 4 units up. Okay. So now we know what to do when there's a negative. Well, what about when there's a coefficient in front of x squared besides 1 or a negative 1? So in this case where there's 2x. Well, step 1 is, well, we know that for sure this is not a perfect square trinomial because it starts with 2, ends with 13. Neither one is perfect squares. So step 1 is I'm going to move that 13. That's always my first step is I'm going to take that, move it to the other side, and kind of just clear the slate, in other words. So then what I'm going to do is I'm going to take a look at what's left. So what's left is this part right here. And this part, 2x squared minus 12x, well, that's simply not going to be a perfect square trinomial. That's going to start with 2x squared, right? So what about if I divided that 2 out, though? So if I were to factor that 2 out of the x squared and the minus 12, I'd be left with x squared minus 6x. So now I'm just going to focus on just this part right here. And I'm going to figure out what would I have to add to make just this part a perfect square trinomial. So again, I think about the b, which is negative 6, divide by 2, and square it. That would give me negative 3 squared, which is 9. So I'd have to add 9 here to make this part a perfect square trinomial. So I did that. I made it a perfect square trinomial. But what did I really add? Well, what I really added to this right-hand side is not 9, but 2 times 9, right? So I'm really adding 18 on that side. So when I go over here to this other side, I have to add 18, okay? Because you want to keep it in balance. Whatever you add to the right side, which is 2 times that 9, when we go to distribute that 2 back through, if we were to do that, we have to add 18 to the other side. So now let's clean this up. So on this side we have f of x, and then negative 13 plus 18 is plus 5. Over here we have the 2, and now we could take and factor that perfect square trinomial. And if we write it as a square binomial, it'll be x minus 3 squared. And then now, final thing is, subtract the 5 from both sides. And subtract the 5 from both sides, leaving me with 2 times x minus 3 squared minus 5 is what f of x is equal to. And again, we have it now in vertex form. We can see this is a vertical stretch of factor 2, slide 3 units right and 5 units down, putting the vertex at 3, negative 5. So in each of these last two cases, when we saw something that was a leading coefficient that wasn't just going to work for us as far as making a perfect square trinomial, we just factored it out and then just completed the square with a much easier x squared plus bx, right? Or plus or minus bx. And then we, of course there's implications to that, whatever we factor out. But as long as we're accounting for that when we're figuring out what to add to the other side, we're keeping things in balance, okay? So I'd like to take a look at a few more like that before we tackle what happens when the middle term is odd, because that's probably maybe one of the most tricky. So let's take a look at number 8 and number 9, and possibly we'll even look at number 10, and then we'll go back and look at those other ones. So looking at number 8, notice this time I don't even have a C term. See, there's no C term. Well, that actually makes it a little bit easier because I don't have to bring anything to the other side to start. But I do, even though that starts off with 4x squared, that still makes it difficult for me to complete the square when it has a leading coefficient like that, because then I'm not just doing using that b over 2 squared. I'm not just taking half the middle term and squaring it anymore, because remember that middle term then is coming from, it's twice the product of the square root of the first and the last. So that's going to change things. So I want to get rid of that 4. And basically what I'm trying to say is I want to start off always my perfect square trinomials with just x squared. So I'm going to factor that 4 out. And that's going to leave me with x squared minus 2x. Okay. So remember I have f of x over here. And so then I got to figure out what's going to make this a perfect square trinomial. So I got to create a perfect square here. So I'm going to take half the middle term, which will be -1, and when I square that, I get 1, positive 1, right? So I added 1 to make this a perfect square trinomial, but what I really added was 4 times 1, right? Because there's that 4 that would be distributed through. So what I'm adding to the other side is positive 4. Okay? So now I'm going to go ahead and rewrite this as a square binomial. It's going to have the sign of the middle term, so it's going to be a minus. Take the square root of the first and the square root of the last. Okay? And then finally I'm going to subtract this 4 from both sides. So bring it back over to the other side so that I just have f of x here. So that would be 4 times x minus 1 squared minus 4, which means it's a vertical stretch of 4. Slide 1 to the right and 4 down. My vertex is at 1, -4. Okay? So we're cruising, right? Now here we go. So look at number 9. Now number 9 has a constant term. So step 1 is I'm going to take that, move that guy to the other side, right? So that's going to make f of x plus 46. Okay? Now I think about, well, I got that -2. I want to factor out this -2 out of these left terms, okay? So if I factor out the -2, that leaves me with x squared, precisely what I want. And then 20x divided by -2 would be -10x. So next step is to complete the square. So I'm going to take half that middle term. So let's see, -5 divided by, oh, sorry, -10. I was ahead of myself. -10 divided by 2, and then square it. So that's -5 squared, that's 25. But I did not really add 25. I added -2 times 25, which is -50. So on this side, I'm really going to add a -50 or subtract 50. Okay, so now I'm going to go ahead and factor this side down. It's a perfect square trinomial now. So when I factor it, it's going to give me an x minus 5 squared. When I simplify the left-hand side, positive 46 minus 5 is -4. And then last step is add that 4 to both sides. And that gives me my answer. Actually, I think I'm going to do this. I'm just going to write it right here to not have to rewrite that whole thing again. So when I get rid of it on this side, that's gone, right? F of x is equal to -2 times x minus 5 squared plus 4. So there's a reflection of the x-axis, a vertical stretch. I'll slide 5 units right and 4 units up. The vertex is at 5, 4. Okay. So one more like that. So this time on number 10, our leading coefficient is -1/2, right? So step 1, of course, is always to bring the constant term to the other side. So I'm going to do that. In fact, I'm going to see. I might have to move up into a different part of this, so I'm running out of space here, but we'll see if we can fit it in there. So if I bring that 5 over to the other side, I'm going to have to add it, right? So that's a -5 added over here. So that's f of x plus 5. Okay. Now, on the other side, I have a negative, I have this part, -1/2 x squared minus 4x. So what I'm going to do is I'm going to factor out the -1/2. So if I divide -1/2 x squared by -1/2, that just cancels out. But if I divide -4 by 1/2, remember dividing by a -1/2 is like multiplying by -2. That's actually going to make that, oops, so we have x squared left. And if I divide that out of the negative 4x, I have positive 8x. So I have x squared plus 8x, and so now I want to complete my square, so I take half of the 8, which is 4, and square it. So I'm going to add 16. But I really did not add 16 to the right-hand side. What I really did is add negative 1/2 times 16, which is negative 8. So over here on this side, with that f of x plus 5, I have to add a negative 8 or a minus 8, right? And then I have the negative 1/2. If I factor this down using perfect square trinomial, that'd be an x plus 4 quantity squared. And then once I simplify this side, I know that first of all, positive 5 minus 8 is negative 3, right? And then all I'd have to do is just to add the 3 to move it to the other side. Okay, so giving me a final form of, f of x equals negative 1/2 x plus 4 squared plus 3. So vertex at negative 4 and positive 3. So that this time this is a, I'm going to make sure that looks like it's a negative, that this is a reflection over the x-axis. That's a vertical compression, so it's going to flatten it down, make it half as tall. Slide 4 units left and 3 units up. Okay. So as long as you follow those same steps, anytime you have a coefficient, once you move the constant term, you're just going to divide that off and just always start off your perfect square trinomial with x squared, okay, as your leading term. And that always makes things easier. Okay, so the final type we're going to look at is a little more challenging for, not because it's got a leading coefficient, although sometimes they do, but because it has a negative, I'm sorry, not a negative, but an odd middle term. So, for instance, number 5. So remember how when we create this perfect square trinomial, okay, by adding half of b squared, okay, what about if we were trying to take half of an odd number? We would get a fraction, right? And so that's what makes these challenging. So, okay, so first of all, same steps though. We're going to get the constant term to the other side. I'm going to move that negative 2 to the other side by adding it. So I'd have f of x plus 2 over here. On this side I have x squared minus 3x. So to create that perfect square, I'm going to take half of negative 3 and I'm going to square it. Now, if I left it as a fraction and I squared it, squaring negative 3 makes 9 and squaring 2 makes 4, I would be adding 9/4 to this side, which means I'm also adding 9/4 to this side. Now, if you instead wanted to turn that into a decimal, you could take negative 1.5 and square it, which is positive 2.25. So you could also put this in as 2.25. So you're adding 2.25 instead, okay? Either one of those is perfectly fine. You can use a fraction, you can use a decimal, either that you like. It might be easier in this case to use the decimal, and that's because you're going to be adding it to 2, so that's fine. So we're to the point where we can write it as a square binomial. So all we have to do is take the square root of the first and the square root of the last. Okay, so that would be x. And then it's a little bit easier to square when you leave it as a fraction, right? So the square root of 9/4 would be 3/2. And then the sign, of course, is the sign of the middle term. And so you have to subtract. Sorry about that noisy dog again. She just got done eating. So x minus 3/2 squared, right? Then on the other side, when you've put the 2 and the 2.25 together, that's f of x. So let's see if I fix this. This would be f of x plus 4.25. So we'd have to subtract 4.25 from this side. So just in the case of having that odd number here, oops, it's going to make for not like maybe the nicest vertex. So the vertex you could write, again, if you want to write this as a decimal, you certainly can. So you could write it as 1.5. So the x-coordinate is 1.5 and the y-coordinate is negative 4.25. So decimals are fine, fractions are fine. So you could write this as 1.5 if you wanted. Okay, either way, decimals or fractions. So we'll go ahead and try one more, and then we'll leave the remainder of the notes as some warm-up questions for our next class. So as we've been doing all along, the first step is if there is a constant term, we're going to shoot it to the other side. So that would be f of x plus 22. So now what's left is this negative x squared minus 9. All right. Well, first of all, I don't want to deal with that negative out in front. I need to have that be positive, so I'm going to take out a negative 1. And what's left then would be x squared plus 9x. So what I'm going to have to figure out is what am I going to add to make this a perfect square trinomial when I'm just focusing in on this now. Like I just want to direct all my thoughts to x squared plus 9x plus blank. What does blank have to be? Well, 9 divided by 2 is 4.5 squared. So for me, it's easier to just take the fraction 9/2 and square it, because that would be 81/4. But of course, certainly that's probably not the nicest thing to be when you have to add it to the other side. So that would be, let's see, 81/4 is in a decimal would be 20.25. Let's see if I can fit that in there. 20.25. It's not going to fit very well. But I really didn't add 20.25 to that side, right? What I really did was I added negative 1 times 20.25. So really on the other side, I have to subtract 20.25. Okay, so that's a little bit of a mess. So now I'm going to clean this up. So let's see, this is f of x. And if I take 22 and I subtract 20.25, that leaves me with 1.75. And then over on the right-hand side, I have negative 1 times, all I have to do is take the square root of the x squared, which is x, the square root of the 20.25, which is the same as what we got when we took half of the middle term, right? So that would be 9/2 or 4.5. The sign comes from the middle, so that's a plus, and then squared. Now it's in factored form. And then our last step is to bring this 1.75 to the other side by subtracting it. So my final function would look like this. Negative, I don't have to put the 1, x plus 4.5 squared minus 1.75. And my vertex, although not pretty, is negative 4.5 and negative 1.75. And you've seen vertexes when we did the standard form ones that sometimes turned out to be decimals. I remember one on our assignment the other day was like 1.5 and 8.25 or something. And so that happens. That certainly happens. None of these are we're in a real world. We're not going to have all nice, easy numbers. So we'll leave the remainder of these problems, the 2 at the end where we're going to graph. We'll put them in a vertex form and graph them, and number 7. And we'll leave those for some warm-up questions. I mean, feel free to give them a try if you want to. I'll also post other videos with some examples that might help you. But this gives you a good source. You've got some problems like really pretty much anything you're going to encounter. Odd middle terms, coefficients out in front, negatives in front. And we've really looked at how you can tackle completing the square to get a standard form equation into vertex form. And so that does it for our class today. I will see you soon.